Okay, the second one is just based on the factorization theorem. So this one is called as Fisher-Neyman factorization theorem. Okay. So again, we build up the joint PDF, but we divide into two parts. Okay, the first part, you have this one. Okay, function G. So function G, you have the include your T. So where your T is your function of your sufficient statistic and also parameter data. Okay, the second part is your function H. Your function H does not depend upon data. So if we can split your joint PDF into two parts, okay, so that means you have your T is sufficient statistic as long as your function H does not depend upon data. Okay, so that is your value or your definition or your theorem for factorization theorem. Okay, so one more thing that you have to note that, okay, if theta heat is sufficient for theta, okay, then any one-to-one function of theta heat, since your sufficient statistic in this case is not unique, so it can be one or more sufficient statistic for the same probability density function. Okay, so as long as it is one-to-one function, for example, we have k theta heat plus k. So based on our previous example, we have x bar. So x bar can be written as summation xi over n. So again, your x bar is sufficient statistic and your summation xi is also a function of the sufficient statistic. Okay. So this is our previous example. So we want to show that our product is a sufficient statistic. So again, the first step, we construct the joint PDF. Okay, and then we split into two parts. So the first part depends upon data. The other part does not depend upon data. Okay, so we can split that one. So based on factorization theorem again, in this case, the product of x1, x2, xn is a sufficient statistic for data. Okay, sometimes we write like this. Let's say if we have t, x is just a product of xi. So this one is your sufficient statistic. Okay. So next example, we proceed with theta over x to the power theta plus 1. Okay, same thing. Construct your joint PDF and then split into two parts. So in this case, you have your function t, okay, function t. So the product is 1 over, so this one is 1 over, okay. Since the location or your situation for your x1, x2, xn is 1 over, okay, product of xi to the power theta. So that's why our product 1 over product x1, x2, xn is sufficient statistic for theta. Okay, it depends on your PDF. Okay, this example is based on normal distribution. Okay, the same thing, but we give you the case wherein sigma square is known. Okay, so for normal distribution, let's say you have normal mu, okay, so normal mu sigma square. So the first case that you have to consider, so let's say you have case 1, so we have several cases. So case 1, let's say mu, okay, your mu, so mu is unknown, your sigma square is known. Okay, you can find that one for sufficient statistic. So your case 2, either mu is known, but your sigma square is unknown. And then for third case, both parameter are unknown. Okay, so in this example, we only show that for case 1, case variance sigma square is known. So for case variance sigma square is known, you find your x bar is a sufficient statistic for theta. But it's depend. So it's depend on the other cases. It can be summation si square, summation s bar, summation si. So it's depend on your case how you want to expand your PDF and find the sufficient statistic. It not necessary to be X bar is sufficient statistic for all three cases. Okay. So again, we proceed this one. So you have your case sigma square is known. So we set up the joint PDF. Okay, in this case, we have 1 over sigma square root 2 pi to the power n exponential summation xi minus theta square over 2 sigma square. So in this case, we expand this one, summation si minus theta square, because we want to show that x bar is sufficient statistic. So in your equation, the term x bar is not provided. Okay. So since the term x bar is not provided, so that means you have to add additional term which is minus x bar and then plus x bar. So it will be cancelled out. Okay. We expand this formula. So this is quadratic. So expand this formula, you have summation si minus x bar square and then plus n x bar minus theta square. So the reason we have n because we don't have xi. So that's why you have n x bar minus theta square and then you have 2 summation si minus x bar minus theta. So the same thing lah, you expand the formula a plus oa minus a plus b square, same thing. Okay. So we note that 2 summation si minus x bar minus theta is equals to 0. Since this one, if we have summation si, so it also can be summation xi minus n x bar. Okay, so x bar you can express in terms of summation si over n. So that's why we cancel out n. So it will give you 0. Okay, so since this term is already 0, so what we have here is just this function. So k sigma square is known. So that means this is your function t. So in this case, your sufficient statistic tx is just your x bar. Okay, so in this case, x bar is a sufficient statistic for theta. Okay, any question? Boleh faham tak? Any question do you want to ask so far?